Thank you very much, Alex. Can you, yeah, I may as well move to the next slide. Thanks. So yeah, I am leading a group that is funded by PDART for 3 years to produce a global, in quotation marks, geological map of Pluto's surface. That is the 75% that New Horizons managed to image back in 2015. So this project began in earnest back in May of last year, and at the moment intending to, I think I can sort of finish the initial draft by May 2021. So I hope to be, for the whole map to be published in 2022 or so. A global geologic map of Pluto will be a valuable scientific product for the community. It will certainly, one of the main ways in which it will help is to allow us to sort of chart the sort of the history of volatile mobilization across Pluto. Much of its geologic diversity stems from surface-atmosphere interactions with sort of the degree to which sublimation and condensation of volatiles occurs, being very much sort of location, latitude dependent due to Pluto's very high obliquity. And this is particularly pertinent with respect to Tombol Regio, the big bright heart feature at the center of Pluto's encounter hemisphere, which is mostly taken up by Sputnik Planitia, the giant deposit of nitrogen ice that has been referred to as the beating heart of Pluto. So yes, the map will let us sort of investigate sort of how Tombol Regio has modified its surroundings in the past. But Pluto also shows evidence for endogenic processes, perhaps most explicitly the tentative cryovolcanic mountains sort of in the southern encounter hemisphere. So passing out exogenic and endogenic processes, the map will very much help us to do that. So the map, the equatorial mapping scale is 1 to 7 million, so about a 7-kilometer minimum feature diameter, and that's for the encounter hemisphere. Remember, this was a flyby, so we have good data for the encounter hemisphere, but for the sort of lower resolution data on the far side, it'll be generally tens of kilometers of the smallest feature we can map. Mercator projection between 57 south and 57 north, and purely a stereographic north of 55. The southern hemisphere was mostly in darkness, so there won't be a southern pole to map. And again, since it's a flyby, sort of we must consider variance and sort of various mapping parameters like pixel scale, incidence angle, emission angle across the map when we're defining our units. So you can go to the next slide, please. So yeah, this is the mapping area we're dealing with, the encounter hemisphere. The imaging quality ranges from 76 meters per pixel to 890 meters per pixel. And at the bottom, we have this bonus mapping that Pluto's atmosphere gave us. So this was nominally in darkness during flyby, but some of the haze scattering allowed us to get some dim imaging of this crosshatched zone here. And the far side on either side is much lower quality, 2.5 to 32 kilometers per pixel. So when we began this last year, we defined 6 geological groups across the encounter hemisphere, with each geological group being a suite of units that represent sort of a distinct geologic episode in Pluto's history. Sorry about the grayscale, this is made for a book chapter, but these are in order of from youngest to oldest: the Sputnik group, the nitrogen ice filling the Sputnik basin, the right group, the cryovolcanic at the bottom, the Tartarus group of the bladed terrain in the east, Hayabusa and Venera, sort of variably mantled terrains in the northeast and northwest, and then the most ancient, the Bernium group, which consists of sort of the sort of ancient, very cratered and often glaciated highlands of the rest of Pluto. So, okay, next slide, please. So, as of now, I've completed mapping of the Sputnik, right, Tartarus, and Hayabusa groups, as well as all the tectonics across the encounter hemisphere. Sorry, I don't have a presentation ready, Domu, to show just yet, but I'll just sort of breeze quickly through some of these. So the yellowish stuff you see in the middle, that's the Sputnik group, consisting of the various sort of planes units, the biggest distinction being between the cellular planes in sort of the north and center, and the non-cellular pitted planes in the south. The brownish stuff you see to the west of that are the Sputnik mountain ranges, which are actually going to be part of the Bernian group because they consist of sort of ancient water ice crust that's been broken apart and sort of stuck as a giant log jam at the edge of Sputnik Planitia. Down south, let's see, yeah, down south you've got the right group. So again, the sort of the red is right Mons, the darker red is Picard Mons material, and with some material, the pink, purple, and violet stuff you see to the west is possibly some stuff we think is in limbo between Bernie and Wright. It sort of shows similar characteristics of both of those groups, so it may sort of exist outside of any of the actual Plutonian groups. And at the bottom left, I think I'm probably going to leave that area blank. That was originally supposed to be mapped, but I think the data quality is too poor there to really include anything. And Tartarus is the green stuff, the bladed terrain in the center. Tartarus and the east and the bright pitted uplands, the lighter green to the left of it. And extending into the polar region for the first time, we have the mantoured terrain of Hayabusa, which sort of shows a lot of accretional textures here. So a lot of smooth edges to sort of topographic relief. So next, last slide. And also the far side mapping has been completed. I was originally going to do this last, but Alan Stern created he was the lead author of this paper that's just come out in Icarus on Pluto's far side. So I completed the mapping for that. And once I finish the encounter hemisphere mapping, the line work of this is going to be incorporated into the USGS map. And so there are I think at the moment there's the count of near-side units is 38, and there are 12 separately defined far-side units, given the great schism in data quality. But in this map, you can see the bladed terrain is red here, so you can sort of see how far it extends around the Pluto's far side. One of the major results of this study, just how much more extensive bladed terrain is than we originally thought. So yeah, remaining work to do is sort of map the more ancient groups and units of Pluto's near side, and so hopefully we'll have that ready for submission sometime in the middle of 2021. So thank you.